Hello everybody and welcome to another C++ tutorial for beginners. In this video, I'll be covering maps. Now a map is an associative data structure that allows you to associate a key with a value. So it's just a different way to go about accessing elements, and it has some kind of efficiency benefits which I'll talk about in this video. So as I was saying, what a map allows us to do is access elements based on a unique key, not based on something like an index or indices. So when we were looking at an array and we had maybe 3, 4, 5, 6, the way we accessed these elements was based on the order in which they were in the array. So the first element was accessed with index 0, second with index 1, so on and so forth. And the order in which these elements appear really mattered. That was the way that we accessed them, and well, it was maintained in this structure. If I had elements that were 3, 4, 5, 6, every time I look at this array, I'm going to have 3, 4, 5, 6 in that order. Now, what this means is that we can maintain the order of elements, which is great. A lot of times we want to do that. We want to know which element was in which position and whatnot. But this also means that if I want to, say, look for something in this array, I want to determine if the element, say, 7 exists, I need to look through every single element in this array to determine whether A, it exists, or B, it doesn't. What I mean by this is the following. If I have this array and I ask you, does element 7 exist? And you need to write code that tells me if element 7 exists, you cannot be sure if that exists or not until you look through the entire array. So if you look through the array and you find element 7, you can immediately stop and you can say, yes, I found element 7, it exists. But if it does not exist, you need to look through every single element to tell me it doesn't exist. Because if you just look through half the array, what's to say it couldn't be in the other half? If you look through every element except one, what's to say it's not that last element, right? And so what that means is that if you're searching for something in an array, this is what's known as a linear time operation. If the array gets larger, it takes you longer to search for it. Now, of course, there's some exceptions. If the element's the very first element in the array and you're looking from left to right, you'll find it immediately. But if we're talking about kind of a worst case scenario, we can always assume the element either doesn't exist or is at the end of the array. And in that situation, however long the array is, well, that's how long it's going to take you to tell me if this element exists or not. Now, this is different in a map. In a map, the order in which elements are inserted does not matter, and it's not maintained. So if you're using a map, you need to be sure that you don't care about the order of different elements. However, this gives you some efficiency benefits. This actually means, and I won't go into exactly how this works, you can access an element and determine if it exists in constant time. Really, what that means is that it doesn't matter how big the map is. If the map has 2 elements or if it has 10,000 elements, kind of generally speaking, you'll be able to determine if an element exists almost instantly, no matter how big the map is. So this is a huge kind of efficiency booster if you're writing some type of program that's kind of searching for something or looking for something or needs to access or change an element and you're not sure if it's actually there in the map. So let me show you kind of a visualization of a map. You have some key. These keys will all be the same type, but they can be any type that you want. So in this case, I'm picking a char or character as my key. And then a value, this value again can be any type that you like, but all of the values must be the same. And in this case, the value is 7. So what I'm doing here is just making a map where I have T and that maps to 7 and S and that maps to maybe 8. And then we have maybe a lowercase a and that maps to 4. Now, obviously, I haven't actually fully created a map in the way we would in C++, but this is kind of what a map looks like. We have what's known as pairs. These pairs have 2 attributes on them. They have a first and a second. So the first here is the key. The second here is the value. And will you use this key to either change or access this value? And I'll show you some examples later on. Anyways, though, let's actually create a map. So I'm going to copy this because I'll use this in a second. But we first need to include the map library. So I'm going to say include and then map. All right, so now I'm going to say map. I'm going to do my 2 angle brackets. I'm going to say int, or I'll do whatever my types are, sorry. So my key is going to be char. My value is going to be int. I'll give the name of my map. And then if I just wanted to make an empty map, I didn't want to put anything in it to start, I would just stop like this, and now I've declared a map. Now, if I wanted to initialize this map with a value, I would say is equal to, and then this is exactly what I would type. I would do 2 curly braces, and then whatever my kind of pairs are, I would write in this kind of format where I have curly brace, my key, comma, my value, closing curly brace, comma, and then the rest of my pairs. So let's just run this, make sure we don't have any errors. All right, everything is good. And well, now we can continue. So first thing to see here, how do we access an element in a map? Well, to do this, we use a similar notation to what we use for an array. So I would say cout MP, which is the name of my map. And then here, instead of an index, I would say my key. So I'd say maybe S. And I can do end L. Oops, we just need one semicolon there. And if I run this, we get 8, right? Because S maps to 8. If I do A, we get a 4 because A maps to 4. And T, obviously we get a 7 because, well, T maps to 7. Awesome. That's basic. That is how you access the element associated with a key. Now, what happens if you try to find a key that doesn't exist? Well, if I do something like MP and maybe U, notice that we just get 0. The reason we get 0 is because this key doesn't exist. And so when it tries to find what's associated with U, it's just returning to us whatever the default value of this type is, which is a 0. And so the thing is, though, this doesn't really tell us that U doesn't exist, because U could theoretically map to the value 0. And so if we want to check and kind of get a true or false value to determine if a key actually exists, what we need to do is kind of something special, which I will show you in a few minutes. Anyways, just keep that in mind, that if you do something like this and the key doesn't exist, it's not necessarily going to throw an error. It's just going to give you some value that's kind of meaningless. Like this 0 doesn't really tell us anything, because if we don't know if it maps to 0 or if 0 is just the default value and it's returning to us, because U doesn't exist in the map. Anyways, let's continue. So now what I'm going to do is I'm going to add U to the map. So to insert an element into the map, you can say MP. You can say the key you want to insert, and then is equal to, and then let's just do like 9. So now if I do this, you're going to see that we get 9 here because, well, now the key U exists in the map. Now there's another way to insert keys into the map. I'll show you this. It's called mp.insert. And what this takes is a pair. So this here is kind of the informal notation of a pair. Now, the way you actually create a pair, you kind of initialize a pair if you're doing it in the most C++ structured typed way, is you write pair. You write the 2 angle brackets, you write the 2 elements you want in the pair. In this case, I'm going to say char int because it needs to match the pairs that are in my map. And then I would do the name of the pair, although in this case, I don't really need to. And then I would just do the parentheses and I would put the elements I want in this pair. So I could say maybe S, or let's do a like J, and let's make that map to 5. So now if I look at J after adding the semicolon here, you're going to see that we get the value 5. So this is how you create a pair. Notice that I could have done something like this. I could have said pair char int and then say something like P1 and then do this. And then I could actually insert the pair P1 into this map. And while the same thing would work, this would be fine. The only difference in this line here is I need to give my pair a name, because I wasn't just immediately using it somewhere. I'm kind of storing that this pair P1 exists and has these 2 values in it. So hopefully that's kind of clear, but this is what a pair is. Now, what I want to show you with a pair, though, is that a pair has 2 attributes on it. As I said, a first and a second. So if I'm looking at P1 and I look at its dot first, that's going to give me J, right? And if I look at its second, that is going to give me 5. And so all of the elements inside of your map really are pairs. Like that's actually what they are. And so whenever you're accessing a kind of pair in the map, you can look at the key and the value by looking at the dot first and the dot second property. So hopefully that's clear, but that's obviously how you insert a pair into the map. Now what I want to show you is a few other things that we can do. So these are kind of the 2 ways to insert elements, but now how do we erase an element? Well, to erase an element, what we can do is say mp.erase, and then we can put the key that we would like to erase. So in this case, I will erase the P1 dot first. That is going to be the J, right? And now if I try to access from my map, the, MP, let's access the key J, you're going to see that we will get, we need a semicolon, sorry about that. You'll see that we get a 0 because we deleted this key from the map. So that is the way you can erase keys. Use erase, you use the key that you would like to erase, and then it will remove that pair. Awesome. Next thing we can do is clear a map. So to clear a map, you can say mp.clear. This will effectively do the same thing. It just removes everything from the map. So sorry, not removing an individual key, just completely emptying the entire map. So I say mp.clear. Notice we get a 0 here because obviously, well, the map has nothing in it, so the key J is not there. Now, there's another thing we can do. We can check if a map is empty. So I can say mp.empty. This will return to me a 1 if it is empty and a 0 if it is not. So we should get a 1 here because, yes, the map is empty. However, if I remove this clear, and now I look at it, the map is not empty, and so we get a 0. Now, next thing we can do is look at the size of a map. So I can say mp.size. This gives me the number of pairs that are in the map. In this case, that is 5. And that is kind of the basic maybe methods on a map. All right, so the next thing I'm going to show you how to do here is how to iterate through the values in a map. So remember that a map does not store the order in which elements are added. And when we want to access or check if something exists, we can do it relatively in constant time, meaning that it doesn't matter how big the map is, we'll be able to find something or change that thing pretty much instantly. Anyways, how do we loop through a map? Well, I'm going to write a for loop out here, and I'm just going to write out what we would need to do to iterate through it. Then I'll kind of go through step by step and explain what I'm doing. So I'm going to say auto itr is equal to, this is going to be mp dot, I believe this is begin. And then I'm going to say itr does not equal, and then this is going to be mp dot end. And then I'm going to say plus plus itr. So I know this is probably extremely confusing, but let's go through it line by line. So mp dot begin. What this gives us is what's known as an iterator object. Now, these are a little bit confusing, but the idea is whenever you have a collection data type, so a data type that stores more than one element, typically they implement something called an iterator. What that means is that you can use this iterator to kind of loop through this structure, because you can't just kind of set up your own for loop and maybe count from 0 to 4, right? Going through all the indices of the map. That doesn't work because you don't access elements based on their indices. So instead, these data structures have an iterator. Now, when you say dot begin, what this gives you is an iterator object. This iterator object has access to the first pair in the map. Now, I want to clarify here that you do not know what the first pair is going to be. The reason you don't know is because the map does not maintain any specific order. And so when you say mp.begin, you cannot be certain where you're going to start, but you know that you will be given the first pair in the map based on however it's storing the different elements. And then when you increment the iterator, what this will do is move this iterator to the next pair, and then to the next pair, and then to the next pair, so on and so forth. And eventually, when you get to mp.end, this tells you you have iterated through the entire map. So there is this .end thing, and well, as soon as the iterator reaches this mp.end, this means you finish the entire map, you've looped through it, you can stop. And so these are the two things that you can use, not just on maps, but on a lot of other kind of collection data structures that store multiple elements. For example, you can do this on a tuple as well, to determine or to be able to loop through the structure. Now, there's some other fancy things you can do with this. I won't really go into those, but when you're creating a for loop and you're iterating through something that is not straightforward to iterate through, like you can't just do it like you would an array essentially, then you need to use the .begin and the .end. You need to increment the iterator as you normally would. And the reason I put auto here is because this type is kind of complicated. What the type actually is mp : iterator. I believe that's correct, actually. We can test this out and see if it works. But anyways, I didn't want to write this out because I don't want to explain exactly like how the iterator works and where this type comes from and all of that. So if you're unsure when you use the iterator, you can just use auto and it will just infer the type based on whatever this returns. So I'm going to leave it, actually I'll leave it this, and then we can change it back to auto if that doesn't work. Okay, so now what's going to happen is I am going to be given a pointer to all of these different pairs. So itr will be equal to a pointer to the first pair, a pointer to the second pair, and a pointer to the third pair. Hopefully you guys understand now why I wanted to show you maps later, because we need to understand pointers first. But what that means is that if I actually want to access the elements in this pair, I must dereference it. So if I say cout, and I just try to cout itr, we're going to get an error. So if I run this, nothing works. MP is not a class namespace or enumeration. Okay, interesting. Let me look at this. I'll be right back. Okay, so I made a little bit of a mistake here. I shouldn't have said MP. Instead, for the actual type of this, it is map, the two types that you have. So char, comma, int, and then iterator, and then that is the type for itr. So yeah, I made a mistake, but this is actually what the type is. It's whatever the map is that you are holding. So whatever the pairs are, and then : iterator. Now, if I run this, you can see that well, if I spell iterator correctly, then hopefully that'll work. Okay, so there we go. Now that's working. The error is now on this line, not on this line. Anyways, that's not what I really wanted to show here. The whole point is that I can't just print out itr. Like, this just doesn't work. Reason it doesn't work is because this is a pointer to an object. And well, even if this was the object itself, we can't just print out a pair. We need to print out either the first element or the second element. So anyways, my whole point of showing you this is that itr is giving you a pointer. So if you want to actually access, say, the first element or the second element, what you need to do is first dereference iter, and then you can access the first and second kind of member or attribute of the pair. So if I try to do itr.first, you're going to see we get the same problem here. We just cannot access dot first because right now we're on a pointer and we're trying to say pointer dot first, and well, that's not defined. That doesn't exist. That makes no sense. And so instead, what I have to do is go asterisk. I can put this in parentheses and then dot first. And now we get all of the keys, right? Because now we've dereferenced this iterator, so it's no longer a pointer, it's actually the object. And then we have dot first, so we're getting all of the different key values that are in our map. Now, of course, we can do the same thing for second. So I say itr dot second, and we get 87459. And notice here that this is not in the order in which we inserted elements, right? Like we're getting 8 first, even though 7 was the first element. And then, yeah, we're getting 5 fourth, even though it was the last element we inserted. So just to prove to you, like you can't be sure of what the order is. Now, there is something that's a little bit shorter than doing this. We can actually write arrow second. Now, what this arrow does is exactly what I just wrote. So the arrow is equivalent to dereferencing ITR and then doing dot second. So this is completely equal to ITR arrow second. It's kind of a shorthand notation just to make things a little bit faster. So whenever you have a pointer, if you want to dereference it and then access some attribute associated with that element, what you do is you just use the arrow. So in this case, this is a pointer to a pair. The pair has this dot second thing that we can use. And so since we need to dereference it, we just use the arrow, and then that allows us to actually access this. It's called a member of this class or of this attribute. Now, I'm using a ton of fancy words here. You don't really have to know what they mean. Just understand that this is kind of known as a method or a member or an attribute, and people use those words like interchangeably all the time. Anyways, that's the point of what this arrow notation does. So if I do this now, we see this still works. Again, it's just dereferencing this and then accessing the element. All right, so I'm going to print this out. We're going to do iter first and then iter second. Awesome. There you go. We can see we get the key, then the value, the key, then the value, so on and so forth. All right, so now what I want to do is kind of give you a basic example of when you would actually use a map. Now, the example I'm going to give you is something that you actually might be given in like a really simple coding interview question. Speaking of which, if you are preparing for coding interviews, you should check out the sponsor of this video and the series, which is Algo Expert. As you guys know, Algo Expert is the best platform to use when preparing for your software engineering coding interviews. C++ is a language on Algo Expert, and so if you want to practice your programming problem skills, make sure you look at Algo Expert from the link in the description and use the code TechWithTim for a discount on the platform. All right, so let's resume now. What we're going to do is we are going to create a string. So let me actually erase all of this. I'm going to say string. I'm going to say test is equal to, I'm going to say, hello world, my name is Tim. And then I'm just going to do a bunch of repeated characters here. And what I want to do is I want to count the frequency of all of the characters in this string. So I want something that tells me the character and the number of times that it occurs. Now, if I was doing this without a map, what I could do is maybe make an array, or I could try to do something where like I associate a letter with a number, and like it would be kind of hard to do this. And what I would have to do is loop through this string a bunch of different times, every single time looking for an H, then an E, then an L, then an O, and so on and so forth. Whereas what we're going to do here is use a map. We're going to loop through this string one time, and we are going to create a map that tells us the character, and then that character maps to the number of times it occurs in this string. And so we're going to make a map. We're going to say map. We're going to say char int is equal to, sorry, we're going to call this freq, like F-R-E-Q, and then we'll just make this empty. Now what I'm going to do is I'm going to iterate through this string. So I'm going to say for int I equals 0. I'm going to say I is less than, and then how do you get the length of the string again? I forget. Maybe it's dot length, maybe it's dot size. We'll see. And then I plus plus or plus plus I. Doesn't really matter. All right, I'm going to say char letter is equal to, and then this is going to be test at index I. And let's just start by printing this out to make sure we haven't made any mistakes here. So I'm going to say cout letter and L. Okay, so let's run this. And invalid use of member length. I totally forget how you get the size of the string. Maybe it's dot size. We're just going to experiment here. Let's try dot size. Same problem. I think I need the parentheses at the end. Let's try dot length. And there we go. Okay, so that actually works though. Okay, so now if I go through here, you can see we're printing out all of the different characters. So hello, my name is Tim, or hello world, my name is Tim, and then TTTHHHAAA. Okay, awesome. So now we've gotten all of the letters. So what I want to do now is I want to kind of count the number of times that they occur. I'm going to use the map to do this. The idea is I'm going to check if this letter exists in the map. If it does, I'm going to change the key associated with that letter to be one greater than it was before. So by default, you can imagine that all of the letters are in this map and they have a key equal to 0. So as soon as I see this letter, I want to go in the map, increment the key by 1, and then continue. And then if I see that letter again, I'll increment the key again by 1 and again by 1. And so at the very end, my map has all of my frequencies. So the way that we do this is we need to first check if this, if this letter exists in the map. So I'm going to say if, and here I'm going to say if, and we will do freq dot find, and then this is going to be a letter does not equal, and this is going to be freq dot end. I'll explain how this works. In fact, actually, I'm going to say is equal to. Then what I'm going to do is say map at, and this is going to be letter is equal to 0. Okay, so when I write dot find, what dot find is going to do is return to me an iterator that points to the pair in the map that has this key. And so what this will be equal to, as I said, is just a pointer, right? This pointer is really just an iterator like we saw when we were iterating through the map. And if I wanted to access the pair associated with this key, I would need to dereference it and then look at the first or second member. So the idea here is that if this returns to me the freq.end, it returns to me the ending iterator. That means that this letter does not exist in the map. And so this is kind of how you check if something exists in the map or not. You say whatever the name of the map is, dot find. Now, if this is not equal to the end, that means, okay, you have found this letter in the map. But if it is equal to the end, that means that this letter does not exist, and therefore it's giving you the very end of the map. That's the return value, right? And so if this is the case, if we're getting the end, we're going to say map at letter is equal to 0. So we're inserting a key, and sorry, this should say frequency, which is equal to whatever the letter is that we just found. And then we're setting that equal to 0. And then what I'm going to do down here is say frequency at letter plus plus. Now, this is equivalent to plus equals 1. This is equivalent to is equal to freq at letter plus 1. All of them are the same thing, but plus plus is kind of the shortest and most common way to do this. All this is going to do is take the key value or the value at letter and just add 1 to it. And that's how it's going to work. So now let's actually just see out freq at letter. Let's also see out like a comma here, and then let's see out what the letter is. So we'll see out letter and then end out. So now we can kind of see as it's counting. So let's do this. And notice that what we get is 1H, 1E, 1L, 2L, 1O, 1 space. This is like an empty string, 1W, 2O, 1R, 3L, right? It's counting and giving us the frequency of all of these letters. And so now that we have this frequency, what we can do is print out the frequency of all of the letters that occur. So I'm going to say for, I'm going to say auto, ITR is equal to, and then this is freq dot begin. I'm going to say while ITR does not equal freq dot end, and then I'm going to say plus plus ITR. All right, now what I'm going to do is see out. I'm going to see out whatever the letter is. So in this case, I will say ITR arrow first. And actually, before I do that, oh no, well, actually, we'll just do it like that. And then I will add a colon, a space, and then I will do the frequency. So I will say ITR, and this is going to be second, and then end L. Okay, so we're just iterating through the map. We're going to print out the letter, a colon to kind of separate it from its frequency, then the frequency, and then end line. So if we look at this now, you can see that we now have the frequency of all of the things. So we have 6 spaces, right? We have 1 exclamation point, 1 H, 4 A's, 1 D, 2 E's, 2 H's, 2 I's, 3 L's, and I mean, I don't need to read all of them. You guys get the idea. All right, so that is kind of all I need to show you with maps. Hopefully this was a decent example to kind of bring a lot of the stuff we've done in this series together and kind of show you why we would actually use a lot of the stuff that we've seen. Anyways, if you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another YouTube video.